Hello friends, welcome back. In this video I want to talk about the learnings from building two prototypes and also some of the experiments that I did in preparation for a third prototype or maybe a final build of the Lancelot Speaker. Now, one of the things is that, for example, I started out with a low quality wood, and what happened with that is that the woofer, the wood not being very good, the front bevel could actually move quite easily. So where, for example, you know that Janos from Real World Audio, who came up with the Lancelot design, he uses higher grade wood, and he also uses a small horn, so a little indent that the woofer is placed back, and therefore he probably gets more rigidity around the mounting of the woofer, and he uses better wood, so there's less resonance peaks in there. So when I talk about resonances, I'm more talking about resonant peaks than resonances on the whole. So if you get a high grade wood, it will not exhibit a single frequency that easily. So what I did to counter that 233 Hz peak that I sometimes got, especially with a certain distance to the back wall and so on, is to employ a tapered horn. So I did that in my second prototype, and also I liked the slanted top improved the imaging a bit, so I got a bit more crisp positioning, and so those were optimizations, but they also had their price in frequency response, and I have a smaller bevel as well, so I didn't get any of the resonances anymore whatsoever, and also because of the tapered horn. So, but the thing is, what can happen is, just as in programming, what can happen is that you end up in a local optimum. And what it means, if you have coding, you can have something hunting for an optimal value, and it can find that optimal value, but it might not reach the other one because it needs to go to a trough to go to the other maximum. Now this is what happened here, because I started out with a poor quality wood. It actually translates in that a tapered horn is a very good solution to working with that type of wood, but it doesn't necessarily end up in the best speaker design overall. So what I did this weekend is retrace my steps, do a bit of measurement. So I put the driver in sort of the configuration that Janos has, but that is just the base reflex box, and I just measured the individual components, the driver. So here you can, for example, see in the green line is the compression driver when just 10 centimeters from its mouth, and so you can see it's completely flat between 400 and 400 Hz and 290 kilohertz. So that's very nice. So I thought, you know what, maybe I can actually cross it much lower than I'm doing now, sort of around 900 Hertz there. And then I tried it also with this horn on top, just having it still point upwards, see what the frequency response is. And then I noticed it could even get down to 350 Hertz, but of course it's a little bit more directional, but that didn't matter because we were pointing it up. Another thing that I did is just measured on, put the microphone on an angle. So, and then as I put it from straight above it to the side, what I noticed is that this level starts dropping. So, under 1 kilohertz, it sort of gets a bit of a plateau, and then it shoots up. And then at the end, at the high end, it's also started curving down a little bit, like you see this orange-red line running. So that's as the angle declined. So as you reach 70-80 degrees, it started to do this. And in fact, this is about 90 degrees angle, but more further away. So, and yes, I could get quite good frequency response out of it, quite low with the compression driver. So it actually does stack up, but it's not from all angles when you get that. So if it's straight on, you get a flat response until 400 Hertz and not too far off. And then with the horn, of course, you can project it way more forward if you want it. So what I want to do in the end is sort of give you a bit of comparison between these two, and play a music clip between the two types of speaker. But so then after I did that, I actually ran the woofer and the compression drive without a crossover. So I just attenuated the much more efficient compression driver, put it down on the same level, and just played those two like that. And I was just surprised on how crisp and how transparent and how direct it sounded. So it's, you know, it's much like a super high efficiency single driver, wideband driver. And of course that sounded so good, so I thought, you know what, this is just all the more evidence that you really need to stick with as simple a crossover as you can. And like Janos says from the Real World Audio channel, you have to solve acoustical problems in the acoustical domain as much as possible, and electrical problems in the electrical domain. And so and not have too much things going on in your crossover that can be solved acoustically and take away from the signal. So then I put a crossover in 300 Hertz, and then also did a bit of comparison with the horn, putting the horn on there, but that really didn't make much of a difference when I had it pointing up. The frequency response in room remained the same. It's a bit different when you measure it on top. Plus with this on top you get horn colorations. So that all combined, I eventually ended up with quite a very simple crossover that produces this orange line. So you can see the roam modes are down here. Here it is a bit low. You get here 2 suckouts, which is probably the back wall and the side wall. Just the way it's positioned there, and slightly lower response here. Then it goes up a little bit, and then it slopes down very gently. And this actually doesn't matter that much. That surprised me. So compared, by the way, to these, if you compare the prototype 1 and now this new prototype, this sounds actually much sprightlier than this one. I'll show you in the clips. So it's quite interesting, and it might be because it's sort of a bit higher in our sensitive hearing regions. But anyway. So one thing I started to understand is what Janos had done in maybe adding a super tweeter on top of here. Just slot that in with a little runoff, just the first order, and then and get that filling up the gap without needing to do anything with, so that doesn't interfere with the signal path to the compression driver. And then here having that little horn in the baffle to support these frequencies. So if you then prevent these 2 suckouts and you have a little bit of support down here, you should actually flow the room modes over into that little horn support. Then the woofer drops further, and then the compression driver, the rest starts to gain strength just because of the wavelengths being very small. So it is a bit of speculation, but I think that's sort of how he got to it. Part of what he got to his design, sort of now having really understood the whole part. And of course he also uses a straight transmission line, not a tapered one, so that might, and he said that it also supported the low frequencies. So that'll be very interesting to see how the combination of those effects, how that actually plays out. So, rest me to wish you a good day, and I'll play these 2 clips and compare the 2 things. I'll just be switching it over manually, just putting one cable in, the other cable in, and do it that way. Hope you got something out of that. Don't get stuck with your starting position. Sometimes do a step back, and yes, I'll wish you a brilliant day, and I hope you enjoy these 2 clips and can hear some of the differences.